Good day, everyone. My name is Ignacio F. Garzon II, a 3 BSCEA student from University of Southern Mindanao. So here's my video report on our subject, Principles of Steel Design. Here is the AISC load combination, which AISC stands for American Institute for Steel Construction. And here our load combinations for LRFD and load combinations for ASD, where LRFD stands for Load and Resistance Factor Design, and ASD stands for Allowable Strength Design. So for our first problem, 2.1, a column in the upper story of a building is subjected to a compressive load from the following sources. Dead load is equals to 38 kilopascals. Occupancy live load is equals to 1.7 kilopascals. Roof live load is equals to 18.7 kilopascals, and for our snow load is equals to 19.7 kilopascals. Here is our givens. And for our first question is, if load and resistance factor design is used, determine the factor load required strength to be used in the design of the column, which ISC load combination controls. So the AISC load combination that we're gonna use is the LRFD load combination, the load and resistance factor design. So for our first combination is 1.4D, which is equals to 1.4 times 30.8, which is our dead load, is equals to 43.1 kilopascals. For our combination 2, which is 1.2D plus 1.6L plus 0.5S is equals to 1.2 times dead load, 30.8, plus 1.6 times live load, which is 1.7, plus 0.5 times which is 19.7 kilopascals. So when we're gonna multiply and add this, we're gonna get the answer for combination to the 49.3 kilopascals. And for our combination 3, which is 1.2 plus 1.6s plus 0.5l, which is the same format for our combination 2, we're gonna get the value of 69.33 kilopascals on our combination 3. So our required strength for this column of this for the design of our column is combination 3, which is our required strength is 69.3 kilopascals. Next question, B. What is the required strength of the column? Since our required strength is equals to 69.3, we're just gonna manipulate the formula and we're gonna get the answer for our required strength, which is 69.33 kilopascals also. What is the required nominal strength of the column for a resistance factor of 0.90? So our given required strength is 69.33 kilopascals and our resistance factor is equals to 0.90. Just gonna manipulate the formula and required nominal strength is equals to required strength over resistance factor, which is 69.33 over 0.90, and our required nominal strength is 77.03 kilopascals. Question number 4, letter D. If allowable strength design is used, determine the required load capacity or required strength to be used in the design of the column, which AISC load combination controls. So in this problem, we're gonna use the load combinations for ASD, the allowable strength design, and for our first combination is for combination 1, D is equals to 38 kips, which is our dead load. Combination 2 is D plus L, which is dead load plus occupancy live load is equals to 32.5 kilopascals. Combination 3 is dead load plus snow load, which is 50.5 36.5 kilopascals, and our C4 is D plus 0.5 L plus 0.5 S, which is 30.8 plus 0.75 times 1.7 plus 0.75 times 19.7. That, and our total for our combination 4 is 46.85 kilopascals. So the required load capacity for our column design is suitable for combination 3, which is the required strength is 50.5 kilopascals. So for our question 5E, what is the required nominal strength of the column for a safety factor of 1.67? So required strength determined our required strength is 50.5 kilopascals and our safety factor is 1.67. Just manipulate the formula and we're gonna get the nominal strength is equals to required strength times safety factor, which is 50.5 times 1.67 is equals to 84.34 kilopascals. So our required nominal strength is 83.34 kilopascals. So here's our second problem. A column is subjected to the following loads. Dead load is equals to 26 kilopascal. Occupancy live load is equals to 15 kilopascals. Roof live load is equals to 5 kilopascals. Snow load is equals to 8 kilopascals. Rain load is equals to 5 kilopascals. And wind load is equals to 8 kilopascals. All loads are compression except for the wind load, which can be either tension or compression. So for our first question, if load and resistance factor design is used, determine the factored load or required strength to be used in the design of the column, which AISC load combination controls. So the combination that we're gonna use is from LRFD. So for our first combination is 1.4 times D is equals to 1.4 times 26 is equals to 36.4 kilopascals. C2 combination 2 is 1.2D plus 1.6L plus 0.5S is equals to 1.2 times 26 plus 1.6 times 15 plus 0.5 times 8 is equals to 59.2 kilopascals. Same for our C3, 1.2 plus 1.6 times 0.5 L. And we're just gonna substitute the givens. And for our combination 3, we're gonna get 51.5 kilopascals. For our combination 4, which is 1.2D plus 1.0 W plus 0.5 L plus 0.5 S, we're gonna, and when we substitute the given, and and for our combination 4, 1.2D plus 1.0 W plus 0.5 L plus 0.5 S, and we're gonna substitute the given loads, we're gonna get 50.7 kilopascals for our C4, combination 4. So the answer for our for first question is our combination 2, which is the required strength is 59.2 kilopascals. Second question, what is the required design strength of the column? Our given required strength is 59.2 kilopascals, where the required strength is less than or equal to design strength, which is our design strength is equals to 59 kilopascals also. What is the required nominal strength of the column for a resistance factor of 0.90? Our required strength is 59 kilopascals and our resistance factor is 0.90. To find our nominal strength, we have a formula which is required nominal strength is equals to required strength over resistance factor, which we can substitute the value 59.2 over 0.90, and we're gonna get we're gonna get 65.78 kilopascals for our required nominal strength. Question number 4. If allowable strength design is used, determine the required load capacity or required strength to be used in the design of the column. Which AISC load combination controls? For our combination 1, D is equals to 26 kilopascals. C combination 2 is dead load plus live load is equals to 26 plus 15 is equals to 41 kilopascals. Combination 3 is D plus S, which is 26 plus 8 is equals to 34 kilopascals. For our combination 4 is D plus 0.75 L plus 0.75 S is equals to 26 plus 0.75 times 15 plus 0.75 times 8 is equals to 43.25 kilopascals. Our C5 is D plus 0.6 W is equals to 26 times 0.6 times 8 is equals to 30.8 kilopascals. And for our combination 6 is D plus 0.75 L plus 0.7 times 0.6 W plus 0.75 S is equals to 26 plus 0.75 times 15 times 0 plus 0.7 times 6 times 8 plus 0.75 times h, which is our combination 6 is equals to 46.85 kilopascals. So the combination that we're going to use in this for the design in the column, so our required strength that we're going to use is the combination 6, which is our required strength is equals to 46.85 kilopascals. For our fifth question, what is the required nominal strength of the column for a safety factor of 1.67? The given the given required strength is equals to 46.85 kilopascals and our safety factor is equals to 1.67. To solve our required nominal strength, we're gonna multiply the required strength to our safety factor, which is 46.85 times 1.67, which leads to our required nominal strength for 78.24 kilopascals. For third problem, the loads on a roof beam consist of a dead load of 0.2 kilopascals per feet, a roof live load of 0.13 kilopascals per feet, and a snow load of 0.14 kilopascals per feet. So our first question is, if load and resistance factor design is used, determine the factored load or required strength to be used in the design of this beam. Which AISC load combination controls? So in this problem, we're gonna use our LRFD load combination, which is for our combination 1 is 1.4. D is equals to 1.42 1.4 times our dead load, which is 0.2, which is equals to 0.28 kilopascals per feet. Our combination 2 is 1.2 D plus 1.6 LR plus 0.5 S is which is equals to 1.2 times 0.2 plus 1.6 times 0.13 plus 0.5 times 0.14, which is equals to 0.31 kilopascals per feet. And next, for our combination tree is 1.2 D plus 1.6 S plus 0.5 LR, which is equals to 1.2 times 0.2 plus 1.6 times 0.14 plus 0.5 times 0.13, which is equals to 0.46 kilopascals per feet. So for our for, so the required setter that we're going to use in this beam is the combination tree, which is our required strength is 0.46 kilopascals per feet. Next question is, if allowable strength design is used, determine the required load capacity or required strength to be used in the design of the column, which AISC load combination controls. So in this, we're gonna use our load combinations for ASD, which is allowable strength design. So our first combination is D is equals to 0.2 kilopascals per feet. Our combination, we're gonna use also the combination 3, which is D plus S, which is equals to 0.2. That's 0.14. And our combination 3 is 0.34 kilopascals per feet. And for our combination 4, which is dead load plus 0.75 times live load plus 0.75 times snow load, which is equals to 0.31 kilopascals per feet. So the required strength that we're going to use in the design of our column is combination 3, which is the required strength is 0.34 kilopascals per feet. For our fourth problem, beams will be designed for the roof and floor systems of an office building. The loads for these systems are as follows. For our roof, we have a dead load which is equals to 30 per PSF. For our roof live load, which is equals to 20 PSF. Snow load, which is equals to 21 PSF. And our rain load, consisting of 4 inches of water. For our floor, we have a dead load of 60 PSF and occupancy live load is equals to PSF. Our PSF stands for pound per square feet. For our first question, for each these systems, determine the required factor load capacity for our LRFD. For our LRFD, which load combination controls? For our roof, we're gonna use the first combination, which is 1.4D, which is equals to 1.4 times 30 is equals to 42 PSF. For our combination 2, 1.2 plus 1.6L plus 0.5S is equals to 1.2 times 30 plus 0 plus 0.5 times 21, which is 46.5 PSF. And for our combination 3, we have 1.2 plus 1.6S, and the value of our combination 3 is equals to 69.6 PSF. So the required load capacity for our roof system is applicable for combination 3, which is 69.6 PSF. And for our floor system, we have C1. Combination 1 is 1.4D, which is 86.8 PSF. And for our combination 2, we have 1.2D plus 1.6L, which is equals to 202.4 PSF. So the required factor load capacity for our floor system is the 202 PSF from our combination 2. For our second question, for each of these systems, determine the required ASD load capacity. Which load combination controls? For our roof system, we're gonna use the combination 1, which is B is equals to 30 PSF, and our combination 3 is equals to dead load plus no load, which is 51 PSF. So the load capacity that we're going to use for our roof system is the combination 3, which is 51 PSF. And for our floor system, we're gonna use the combination 1, which is D is equals to 62 PSF. And our second combination, which is D plus L, which is 142 PSF. And our combination 4 is D plus 0.75L, which is 122 PSF. So load the load capacity that we're going to use for our floor system is the combination 2, which is 142 PSF. For our problem 5, structural steel buildings frequently are designed with diagonal bracing systems to resist lateral loads, horizontal forces resulting from wind or earthquake loadings. A certain bracing system is subjected to the following loads. Dead load is equals to 13.3 kilopascals. Occupancy live load is equals to 6.9 kilopascals. Roof live load is equals to 1.3 kilopascals. Snow load is equals to 1.3 kilopascals. wind load is equals to 150.6 kilopascals, and earthquake load is equals to 161.1 kilopascals. For our first question, determine the required factored load capacity for LRFT, which load combination controls. So we have our combination 1, which is 18.62 kilopascals, combination 2, which is 27.65 kilopascals, combination 3, which have a result of 93.34 kilopascals, combination 4 has 170.7 kilopascals, and combination 5 has 180.8 kilopascals. So the answer for this question is combination 5, which has 180.8 kilopascals, which required for our factored load capacity. And for our second question, determine the required ASD load capacity, which load combination controls. For our combination 1, which is D is equals to 13.3 kilopascals, C2 is D plus L, which is equals to 20.2 kilopascals. Combination 3 is D plus roof live load is equals to 14.6 kilopascals. Our C combination 4, which is D plus 0.75 times live load plus 0.75 times roof live load is equals to 19.45 kilopascals. Our combination 5 is the load plus 0.7 times earthquake load is equals to 126.07 kilopascals. Our combination 6A, which is D plus 0.75 L plus 0.75 times 0.6 W plus 0.75 L is equals to 91.15 kilopascals. And for our combination 6B, we have D plus 0.75 L plus 0.75 times 0.7 E plus 0.75 S is equals to 104.03 kilopascals. And our answer for this load capacity is combination 5, which has 126.07 kilopascals. So that's all. Thank you and God bless.